بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. اليوم بإذن الله حنتكلم عن الفود سبويلج بإشراف الدكتورة مشاعل الغامدي، بإعداد الطالبات حنين خالد ورزان بحبيشي وجوري الخثعمي وأحلام محمد وشوق الكثيري وشهد الشهري.
Food spoilage is a metabolic process that causes food to be undesirable or unacceptable for human consumption due to changes in sensory characteristics. Spoiled food may be safe to eat. They may not cause illness because there are no pathogens or toxins present, but changes in texture, smell, taste, or appearance cause them to be rejected. Food loss from farm to fork causes considerable environmental and economic effects.
Causes of food spoilage. Shelf life of a food is the time during which it remains stable and retains its desired qualities. Some spoilage is inevitable, and a variety of factors cause deterioration of foods. Endogenous enzymes in plants oxidizing phenolic compounds, browning, or degrading pectins softening, insects infesting foods, and rodents chewing on foods. Parasites, when visible, for example in meat or fish, rendering food undesirable. Microbes, bacteria, molds, and yeasts growing on a metabolizing food. Light causing degradation of pigments, fats, and proteins of flavor and odors, or stimulating pigments production, greening of potatoes. Temperature, both excessive heat and freezing physically affect texture of foods and breaking emulsions. Air, particularly oxygen, oxidizing lipid producing strong of odors and flavors. Moisture, too little causing cracking, crumbling, or crystallization, whereas excess causing sogginess, stickness, or lumping.
Microbial spoilage of food. Reference to the deteriorates in quality and safety of food products caused by the activity of microorganisms such as bacteria, yeast, and molds. These microorganisms utilize nutrients in the food to grow and reproduce, producing metabolic byproducts that result in undesirable changes in taste, odor, texture, and appearance. Spoilage can render food unfit for human consumptions, and in some cases pose serious health risks due to the production of toxins. These extent and type of spoilage are influenced by various factors, including the composition of food, storage condition, and the specific type of microorganism present. Several physical factors determine whether spoilage microbes will be successful in utilizing the nutrients in food. These include water activity and type of solutes, pH, temperature, storage and processing, oxygen and carbon dioxide levels, solid or liquid state of foods, available nutrients, and preservatives. Models for microbial spoilage of different foods and for spoilage by specific organisms examine the effects of these factors singly and in combination to predict the initiation and course of spoilage process. These models are based on and validated with actual experimental data and can provide useful information for product development and modification, shelf life estimates, processing requirements, and quality assurance programs. Food spoilage is a complex process involving a variety of organisms food preservatives and additives, and food matrices, in addition to temperature, pH, and water activity. The most important determinants of microbial growth, depending on their objective models, are constructed to focus on probability of growth, no growth, time required to initiate growth, growth rate, or survival of spoilage organisms under a particular set of parameters. Inactivation and destruction of microbes exposed to different preservatives or preservation techniques can also be modeled.
Spoilage of different types of food. Fruits and vegetables are highly susceptible to microbial spoilage due to their high water activity and rich nutrient content, which provide ideal conditions for the growth of bacteria, yeasts, and mold. Spoilage in these foods often manifests as softening, discoloration, and the production of off odors. Fungal species such as Aspergillus, Penicillium, and Rhizopus are commonly involved, leading to rot and visible mold growth, particularly under conditions of high humidity and inadequate storage. Yeasts may also cause fermentation in fruits, resulting in the production of alcohol and gas. Because many fruits and vegetables are consumed raw, microbial contamination not only affects quality but may also pose health risks if pathogenic organisms are present.
Factors affecting food spoilage. Growth and activities of microorganisms, principally bacteria, yeast, and mold. Activities of natural foods, insects, parasites, and rodents. Temperature, both heat and cold. Moisture and dryness. Air, and particularly oxygen. Light and time.
Food preservation methods such as refrigeration, freezing, drying, and canning are widely used to delay spoilage and maintain food safety. Refrigeration, 0 to 5 degrees, slows down microbial growth and enzymatic activity, while freezing, -18 or below, halts microbial activity entirely. Preserving food for extended period, drying removes moisture, reducing water activity to a level where most spoilage organisms cannot survive. Make it one of the oldest yet effective preservation methods. Canning involves sealing food in airtight containers and subjecting it to high heat, which destroys spoilage and pathogenic microorganisms. These techniques significantly increase shelf life and reduce food waste when applied properly. In addition to physical methods, the use of chemical preservatives and the evaluation from traditional to modern methods have played vital roles in food preservation. Chemical preservatives such as sodium benzoate, nitrates, and sorbic acid inhibit microbial growth and are commonly used in processed food. Though their use is regulated to ensure safety, traditional methods like salting, smoking, fermentation, and sun-drying rely on natural processes and local knowledge and are still widely practiced in many parts of the world. In contrast, modern preservation methods include modified atmosphere packaging, high-pressure processing, and irradiation, which aim to maintain food quality while enhancing safety with minimal additive use. These technologies offer more control and consistency than traditional methods, but often require higher investment and infrastructure. Detection of food spoilage is critical to ensure food safety and quality before consumption or distribution. Traditional detection rely on visual signs such as mold growth, discoloration, and texture changes, as well as sensory indicators like off odors or sour taste. However, these signs often appear after spoilage has progressed. Modern approaches use biosensors, gas detectors, and chemical indicators to identify early microbial activity or the presence of spoilage gases like hydrogen sulfide or ammonia. For example, smart packaging technologies incorporate colorimetric sensors that change color in response to microbial growth or pH changes. Such innovation allow for real-time monitoring and help preventing the consumption of contaminated food. Preventing food spoilage involves a combination of good hygiene practices, proper food handling, and adherence to regulatory standards at the consumer and retailer levels. Practices such as hand washing, avoiding cross contamination, maintaining proper storage temperature, and using clean utensils are essential in the food industry. Compliance with hazard analysis and critical control points, and good manufacturing practices ensure systematic identification and control of contamination risks. Food safety regulation enforced by agencies such as the US FDA and the European Food Safety Authority establish limits for microbial contamination and dictate labeling, packaging, and processing standards to protect public health. Together, these strategies create a multi-layered defense against spoilage and foodborne illnesses.
In conclusion, microbial spoilage of food poses significant challenges to food safety, quality, and shelf life, primarily driven by the activity of bacteria, yeast, and molds under favorable conditions. The types and severity of spoilage vary across food categories, with fresh products, meats, dairy, bread, and canned goods each exhibiting characteristic signs of deterioration. Effective food preservation methods ranging from traditional techniques like drying and fermentation to modern technologies such as refrigeration, canning, and high-pressure processing play a vital role in inhibiting microbial growth.